Welcome to the course on applied research from hypothesis to structural equation modeling. In this session, we will focus on how to evaluate reliability and validity systematically. In this session, we will focus exclusively on understanding the reflective measurement model in structural equation modeling, particularly using SMART PLS. Although SMART PLS estimates reflective and formative constructs simultaneously when we run the model, it is essential to understand their evaluation criteria separately. Reflective constructs follow a different logic and therefore a different set of rules. Let us begin with the two fundamental steps that must always be performed when running any SEM model in SMART PLS. First, we run the PLS algorithm, and second, we perform bootstrapping. These two steps are non-negotiable. Everything else is secondary. As we have already created a model named as path diagram, you can duplicate it by right-clicking and clicking on duplicate. Once you duplicate, the wizard opens, and now you can give the name reflective model to save the model. Now click on the reflective model to see what has been available over there. You can see the exact model what is available in path diagram is now available in reflective model too. Now let's see how to run the PLS algorithm. Go to calculate and select PLS algorithm. Now if your model consists entirely of reflective construct, SMART PLS also offers something called consistent PLS. This approach was proposed to bring PLS estimates closer to variance-based SEM results. However, it is optional. You may use it, but you are not obligated to. If consistent PLS produces stable results, you can report it. Otherwise, the standard PLS algorithm is perfectly acceptable, especially when formulative constructs are included. Once the algorithm runs, results will appear on the screen. These results include both measurement and structural outputs. For now, our attention is only on the measurement model for reflective constructs. You can find now the R-square value is being identified above the reflective constructs. Now, at any time, if you feel like changing the output which is visible on the screen, we can do it by clicking on the constructs and changing from R-square to average variance or composite reliability, rho A, rho C, or even Cronbach alpha. So now, as we got it initially, we will have R-square. Even the measurement models can be modified into outer loadings or outer weights by clicking on the measurement model. Let's understand reflective constructs. In a reflective model, the construct causes the indicators, which means changes in the latent variable leads to changes in item responses. Indicators are expected to correlate. Removing one indicator does not alter the conceptual meaning of the construct significantly. Because of this logic, reflective models are assessed through four main criteria. The four evaluative reflective model measurement model criteria are internal consistency reliability, convergent validity, outer loadings, and discriminant validity. Let's see one by one. First, internal consistency reliability. Let's go to quality criteria and click construct, reliability, and validity. Here you will find Cronbach alpha, composite reliability, rho A and rho C. The acceptable threshold for Cronbach alpha is greater than or equal to 0.6 or 0.7 preferred. The composite reliability should be between 0.7 and 0.95. If the reliability values are low, the first thing to examine is item wordings. Often, poorly phrased or ambiguous items in the question reduces the reliability. If the wording is correct, then you can move to the outer loadings to find what is the problem and where the problem exists. Second comes convergent validity. Convergent validity is assessed using average variance extracted AVE. The threshold for AVE should be greater than or equal to 0.5, which indicates that the construct explains at least 50% of the variance in its indicators. If AVE is below 0.5, then you have to inspect outer loadings. Third comes outer loadings. Now you can navigate to outer loadings in the results panel. If your loadings are greater than and equal to 0.7, it is an excellent loading. If your loadings are between 0.4 to 0.7, we will consider removing the items if AVE is less than 0.5 or reliability improves. If the value is below 0.4, the outer loading value is below 0.4, the item can be removed immediately. In practice, loadings below 0.55 often create problem, even though theoretically 0.4 is acceptable. If necessary, remove the lowest loading item first. Rerun the PLS algorithm and check the AVE and reliability. If the AVE has improved, then we can stop with that. Else, you can continue removing the other items until AVE improves. Always proceed step by step. Do not delete multiple items at once without checking the impact. The last comes discriminant validity. There are two main approaches used in discriminant validity. One is HTMT ratio and Fernal-Archer criterion. HTMT value should be below 0.85 or at the most it can be below 0.90. If HTMT exceeds the threshold, discriminant validity is violated. Check the HTMT here. Now, if all the values are below 0.85, then there is no issues with the data. Else, we can also once check the Fernal-Archer criterion. Fernal-Archer criterion speaks more about the square root of AVE for each construct, which should be higher than its correlation with the other constructs. If either criterion falls, investigate further to see what has been wrong. You can see the diagonal element 0.910, 0.830, 0.902 and 0.851. It is found to be higher than the other values in the rows and columns. If suppose any of the HTMT value is greater than 0.9, first we have to check the cross loadings. To resolve discriminant validity issues, there are two constructs which has higher HTMT value. Then go to the cross loading. Check whether items from one construct load highly on another construct. Remove the most problematic item first. If the cross loadings are unclear, check indicator data correlation under your model and data. Identify specific items with high inter-item correlation across constructs. Remove the item causing conceptual overlap by seeing the value individually. However, here when checking likability with customer loyalty, like 3 has higher loadings in customer loyalty, hence like 3 can be removed. Again, deleting one item at a time and rerun the model is the best way to do it. Discriminant validity issues often indicate conceptual overlap between constructs. Sometimes the issue is statistical, sometimes it is theoretical. So be conscious, deleting item should not distort the theoretical meaning of the construct. Important reminder, single item constructs are not evaluated for measurement reliability. In the same way, since the item equals the construct, internal consistency cannot be assessed. Measurement model is established only when reliability is acceptable, AVE is satisfactory, outer loadings are adequate, and discriminant validity is confirmed. Then and only then should we proceed to structural model evaluation. After finishing the PLS algorithm, we must run bootstrapping to assess the significance of outer loadings and significance of path coefficients. Bootstrapping provides t-values and p-values which are essential for hypothesis testing. Summarizing, reflective measurement modeling is not mechanical, it demands theoretical sensitivity. Statistical threshold guide decisions, but conceptual clarity must drive them. Removing an indicator improves numbers, but may weaken meanings. Always strike a balance. In the next session, we will move to the formative measurement model, which follows a completely different logic. Thank you.